Alright guys, so welcome to the Unit 2 Quiz 2 study guide. We're going to go ahead and go through the even problems here. So let's begin. So for number 2, the first thing we want to do is integrate. So if I were to integrate that, I would add 1 to the power, and I would divide by that value. And then for the 4, we just put an x next to it. And we put our limits over here. Then we're going to go ahead and plug in our limits. I like to set it up like this myself first. That way I don't forget stuff. It also helps with negatives when you start with parentheses like that. And then we're just going to plug some things in. And then we're ready to simplify. So you got to use your order of operations. So that's going to be a negative 8 over 3. That's going to be an 8. That's going to be a negative 27. Now the negative in the front causes it to become a positive 27. And then 27 over 3 is 9. So that whole thing simplifies to become 9. And this is minus 12. We're going to go ahead and distribute this negative, and after we do that, we can go ahead and drop the parentheses. And from there, we're just going to go ahead and simplify. These three numbers we can go ahead and put together. 8 take away 9 plus 12 gives me what would that be? It'd be 11. All right, and then we need to get a common denominator there for the 11 and the negative 8/3. So put that over 1 and multiply the top and bottom by 3. And then we go ahead and combine those two things together, and we get 25/3. Okay, now I don't mind if you guys use a calculator to do these instead. That's fine. It doesn't matter to me what strategy you use, but that is doing it by hand. If you remember how to do it by a calculator, be my guest. So that's one thing that will be on your quiz, is evaluating a definite integral, once again, by hand or the calculator. Either way is fine with me. Let's go ahead and take a look at number 4. Number 4 is going to be a basic U sub problem. So in this case, my u is the inside part, which is x to the 4th plus 1. The derivative of u with respect to x is going to be 4x to the 3rd. And then solving for dx, we would end up with du over 4x cubed equals dx. Doing our u substitution, I replace this with u. I replace this, the dx, with what dx equals, and that's du over 4x cubed. Those cancel out, and now I have a simpler integral to evaluate. So if I just follow through with the integration process by adding 1 to the power, and then dividing by that value, don't forget to add your c. There's that, but we do want to go ahead and put the u value back in at this point. And so if I replace this u with what u equals, we will have as our final answer that. All right, let's go ahead and take a look at number 6. It's another u sub problem. This time the u, the part in the parentheses, is the 5x squared minus 4. My du over dx is 10x. Solving for dx, we get that. Replacing this with u, I get u to the 4th. Replacing this with du over 10x, I get that. and then the 10x is going to stay there for now. But not for long, because these cancel each other out, and now I'm left with 1 over u to the 4th du. And now we go ahead and evaluate this integral like we have in the past. The first thing you do when you have these fraction ones is you move them to the top and make the power a negative. Add 1 to the power and divide by that value. Don't forget your plus c. Next thing we're going to do is I'm going to rewrite it as negative 1 over 3 u to the 3rd plus c. And then finally we can replace that u with what u equals. So that'd be 1 over 3 and 5x squared minus 4 to the 4th plus c. I'm sorry, not to the 4th. It is to the 3rd. There we go. That's our final answer. So another u sub problem there. All right, let's go ahead and move it along to our next set of problems to work on here. All right, number 8. Here is my u. The derivative of u with respect to x is 5x to the 4th. Solving for dx, we get the following. Doing our u substitution, I replace the inside with u. I replace the dx with that. These cancel out. And now I have a simpler integral. With radicals, we've learned that we change them to a power instead. Remember, with square roots, the number here is a 2 and the number here is a 1. And so, as a power, it's written as 1/2. We add 1 to the power, which is 3 over 2. And then we divide by that number. But, instead of dividing by 3/2, it's much easier just to rewrite that as multiplying by the reciprocal. Now the next thing we're going to do is we're going to replace the u with what u equals. And so final answer here will be 2 over 3 and x to the 5th minus 5 to the 3/2 power plus c. All right, number 10. Number 10 is what I like to call a pain in the butt problem. You'll see why in a minute. So the first thing we do is we take that inside piece there, and we'll call that our u value. Go ahead and take your derivative with respect to x, and then we get dx by itself. And then we go ahead and do our u substitution. Okay, and so this is where things get a little bit unpleasant because the x doesn't go away. So we learned how to handle that. So first of all, I'm going to rearrange my terms a little bit. This 2 and this 5, I'm going to go ahead and put those in the front like this. I'm going to move that u to the 4th on top there with the 2. And I'll put the x here separately. So I like to write that x separately and put all the other stuff together. Now the next thing we're going to do is we're going to come back to this equation here. We're going to solve for x. So let's do that. First thing I'm going to do is add 4 on both sides. And then I'm going to divide by 5. And I find it easier just to put each one of these under, or put a 5 under each one of those things separately. So we have x is equal to u over 5 plus 4/5. So now that I know that x equals this, I can replace this x with what I just got. One more thing before we can actually integrate is we need to distribute this now. So if I distribute that, I'm going to get 2u to the 5th because 4 plus 1 is 5. 5 times 5 is 25. Plus, if I distribute it over here to the other one, 4 times 2u to the 4th is 8u to the 4th. And 5 times 5 is 25 again. All right, so that's the nightmarish part is over with. Now we're ready to just go ahead and do our integration. So I'm going to add 1 to the power. And I want to divide by that number also. Now I've already got a number in the denominator, so what I'm going to do is I'm just going to put the 6 down there with the 25 and we'll multiply them together. Same thing here with the next one. We'll add 1 to the power. And since I got a 5, I'm going to go ahead and multiply that to the bottom also. And we don't want to forget our plus c. Now, if you can, go ahead and reduce. So for instance, 2 goes into 6 3 times. And that leaves me with u to the 6th over 75 plus 8u to the 5th over 125. And then we're ready for our very last step, which is where we replace the u with what u equals. Now u was 5x minus 4. And that would be our final answer there. All right, moving along to our next set here. 12 and 14 is next. Having trouble there. There we go. All right. So now we've done a problem like this with our u substitution already, but in this case we have a definite integral. So when you have a definite integral, we're going to treat it a little bit differently. We have a little bit of an extra step to do there. So first of all, looks like I got moved down to the bottom there. Let me scroll back up here. All right, so my u value is that. Let's find our derivative with respect to x. Let's get the dx by itself. And let's do our u substitution. Now, we're not done with the u sub at this point because it's a definite integral. When you do u substitution, the limits will change also. The way that you find those limits is by plugging these numbers in for x over here. And once you do that, that'll tell you what the u's are supposed to be that go on the integral now. So my top number was 3, so let's plug 3 in for x. That's going to give me 3 squared is 9 times 3 is 27 plus 3 is 30. So the top number now is going to be 30. We will do the same thing now by plugging in the 0. Now, if you plug 0 in here, that's pretty simple. This just goes away and you're left with 3. Right? So when you do a definite integral, you need to change the limits also by plugging those into the u equation. All right, next we're ready to simplify. The x's go away. 6 goes into 12 twice. And now I'm left with this following simplified expression. And we're ready to go ahead and do the process. So step 1 is to move this guy up to the top and make the power a negative. Step 2 is to go ahead and integrate. So if I add 1 to this, I get u to the negative 1. And we'll also divide by that value. Now we're ready for simplifying this a little bit. That u to the negative 1, I'm going to move that to the bottom of the fraction. Also, if you do 2 divided by negative 1, it just becomes negative 2. Now we're ready to go ahead and do our fundamental theorem of calculus, where you plug in each of the limits and subtract them. So I'll go ahead and plug in the 30 and the 3. All right, so notice the double negatives here. So I've got negative 2 over 30 plus 2 over 3. Now if I want to get a common denominator, I'd multiply the top and the bottom by 10. And that would be negative 2 over 30 plus 20 over 30, which is 18 over 30, which reduces to 9/15 is the final answer there. So there you guys have it on number 12. Let's go ahead and take a look at number 14. All right, these trig ones, sometimes it's a little bit difficult to see what the u is. In this case, my u is the inside piece, so u is e to the 5x minus 5 du with respect to x. All right, the 5 just goes away when you take the derivative. And when you take the derivative of an exponential function, it stays the same. But we do want to multiply it by the derivative of the inside. The derivative of 5x is 5. So there's my du dx. Next, we get the dx by itself. And we're ready for our u sub. I'm going to replace this with u. I'm going to replace this with du over 5 e to the 5x. The e to the 5x's go away. The 5 goes into negative 25, leaving negative 5. Now this negative 5 here, we can go ahead and take that out of the integral. It doesn't need to be in there. And the integral of cosecant squared u is going to be negative cotangent u. We don't want to forget our plus c. Now this is a negative 1 in the front, and if you multiply that by a negative 5 in the front, there you get a 5 cotangent u plus c. And we can go ahead and put our u back in at this point, so that would be e to the 5x plus 4. And there's our final answer on that guy. All right, next one, review some FRQ stuff with you guys. Here we go. So the height of a tree at time t is given by the differentiable function h. Differentiable means that you can take its derivative. Where h is measured in meters, so h is measured in meters, and t is measured in years. So basically we have a tree, which after 2 years is 1.5 meters tall. After 7 years, it's 11 meters tall, and so on and so forth. So just understanding the table there. Let's go ahead and take a look at part A here. Part A says find this and interpret what it means, including the appropriate units. So that's a 3-part question. We want to do an integral, and we want to interpret it, and we want to include units. All right, so the integral of h prime is simply h. The integral cancels out the prime. And then using the fundamental theorem of calculus, we're going to plug in the 7, and we're going to plug in the 3. Now, h of 7, that means I'm going to find where the year is 7, and I want to find what's the height that goes with that. So at year 7, the height is 11. So this whole thing becomes 11 minus h of 3. Find the 3, find the h, put it there, and you get 9. So what is this? What's going on here? Well, this represents the height of the tree in the 7th year. This represents the height of the tree in the 3rd year, and we're subtracting those. So what does this tell us? Well, basically that 9 tells us that the tree grew 9 meters on the interval t equals 3 to t equals 7 years. Now remember, when you have an interpretation, you need to include 3 things. You need to include the units of your answer. So my answer is 9, and that's 9 years. I'm sorry, 9 meters, my bad, 9 meters. So I've got my output units here. Another thing you want to include is you want to include the input units. Those are the things that you plugged in here. Well, the 7 and the 3 are years. So I've got my output units there. You also want to explain what it means in the context of the problem. It's telling us that the tree grew that much. Okay, so that's the 3 parts: the input units, the output units, and also the interpretation or the context of the problem. Notice that I said it grew. Why is that? Well, because the height increased by 9. I got a positive number. Now, it wouldn't make sense to have a shrinking tree, but just for discussion's sake, if I had gotten a negative answer here, that would mean that the tree actually shrank over those years. So, but just keep those things in mind. Okay, so there it is. So we've got our integral, we've got our interpretation, and inside of that interpretation we have our units. So I've answered all 3 parts of the question. This question will be worth about 2 to 3 points. Okay, you would get 1 point for doing the integration process with your work shown appropriately, and the interpretation is going to be worth either 1 or 2 points. Like the sentence itself, if it makes sense and written correctly, is 1 point. If you include the units also, that's another point. So now sometimes when they grade these, they just make the whole thing worth 1. So I'm not making any promises right now, but I will say that the interpretation part with the units will be either worth 1 point or 2 points. The actual answer from the integration will be worth another point. So altogether, 2 to 3 points for that first question. All right, let's go ahead and take a look at Part B. Part B is quite similar. It's just a little bit more, convoluted and abstract. So first of all, if I take the integral of this, the 4 is going to stay. The h prime becomes just h. If I take the integral of this, that's going to become t squared over 2, just using the power rule. And if I integrate this, I get 4t. And we're doing a definite integral, so I'm not going to put a c, but I will put brackets with my limits here. And all we're going to do is just go ahead and plug stuff in now. So here we go. We have our setup. Now, I'm going to simplify this. These 2's cancel. Makes it easier for me with less writing. So there's my setup, and now I'll plug in the numbers. The 10 comes first. The 5 comes second. All right. So looking at the table, h of 10 is 15. This is 100. This is 40. H of 5, according to my table, is 6. That's 25. and that's 20. All right, run a little low on space here, so I'll start simplifying a little bit. This is 60, right? So I've got 60 plus 40 minus 100. That whole thing equals 0 if you add those three numbers together. So I'm just going to get rid of it. This is 24. And we want to go ahead and distribute here. So let's distribute. So that becomes a negative 24 plus 25 plus 20. And the final answer there is going to be 21. Now there's no interpretation for this. This is just math. So how are we going to grade it? Well, I would definitely give 1 point for doing the integration and then 1 point for getting the final answer. So this one's not going to exceed 2 points. Okay, so 1 point for the proper integration and then 1 point for the correct final answer. All right, and that will do it for our study guide. Hopefully that was helpful, and we'll see you guys in class.